Question 18, jumping ahead again. We have something that is not difficult, but it brings a few points. I think that's x to the power of 8. Brings a few points of discussion to the surface. First thing I want you to look at is that really this bit here, the integrand, what we want to integrate can be expressed as 1 over x to the power of 8 dx. Frequently, if the numerator is a 1 in the integrand, in the thing that we want to integrate, then it will be, the whole integral will be written with just dx over the function of x. Alright, so if we can recognise that this is actually 1 over x to the power of 8 and integrate that with respect to x, alright, that's the first thing to note. Second thing is, in integration, as with differentiation, always change the function that you want to integrate into index form. And at the moment this has got indices in it, but it's not fully in index form. What will make it fully in index form is if we write x to the power of minus 8 dx, and now it becomes a simple process of following this template. Minus 8 plus 1 will be minus 7, so we will end up with x to the power of minus 7 over minus 7 plus c. All done. Now that is integrated, that's the indefinite integral. We can actually rewrite that in a way that perhaps a textbook would present the answer, and maybe it looks a little bit neater, maybe it doesn't. It's neither, either, potato, potato, tomato, tomato. We could write that as minus 1 on 7x to the power of 7 plus c. These two things are mathematically identical, they just look a little bit different, that's all. That was question 18. Question 23 we're jumping to now. Question 23. We have, again, something that confuses students, but really it's very straightforward. X to the power of 6 minus 3x to the power of 5 plus 2x to the power of 4 all over x cubed, and integrate that with respect to x. That's what we have to do. What makes it easy is there's a common factor of x cubed in the numerator. So we can divide through by x cubed, eliminating the x cubed from the denominator and eliminating that factor from every term that's in the numerator. The new expression would be this: x to the power of 3 minus 3x squared plus 2x dx. And now we use this template to figure out how to do that. Our answer will be x to the power of 4 on 4 minus 3x cubed on 3 plus 2x squared on 2 plus c. And if you want to cancel out these terms here, that's entirely appropriate. And just to tidy that up a bit, we would end up with x to the power of 4 on 4 minus x cubed plus x squared plus c. Okay? So cancelling out is entirely legitimate in this process. Question 31, sorry. We're jumping down to question 31. Another important point with this one, we're integrating the square root of x with respect to x. Okay, always important, just like we did down here, to write all our functions of x with index form, not like that. It's not hard to do, but it just means it's another thing that you're manipulating in your brain to try and get to the answer. So let's try and overcome that by actually writing it immediately in index form. The square root of x is x to the power of a half, and we're integrating that with respect to x. That's what the dx is. That's what it's telling us. We're integrating that function with respect to x. We follow the template again. Now, a half plus 1 is going to be 3 on 2. So we'll have x to the power of 3 on 2 all over 3 on 2 plus c. And as we discussed in class, if you've got this numerator divided by the fraction 3 on 2, ultimately what you will end up with, if you follow simple years 6 and 7 mathematical processes, you'll end up with 2x to the power of 3 on 2 all over 3 plus c. Now we've worked through that in class, and I'll leave it up to you if you're not sure about that to struggle through it, or come and ask me a question later on. Last question, question 34. Excuse me. Question 34. Find the integral of x times the square root of x with respect to x. Again, the key thing always with calculus is get things into index form, which is why from year 9 all the way through till this very moment now, I've said indices are a really essential thing to have a good grasp of, and the index laws. So this is really x to the power of 1. This is x to the power of a half. And if I multiply two functions of x, the base is the same, but the indices, when we're multiplying the bases together, when we multiply these two things together, then the indices will be added. So that will be 1 plus a half. So really what we're integrating is x to the power of 1 plus a half is 1.5, or 3 on 2. And now, once we do the integration, we're going to have 3 on 2 plus 1 will be 5 on 2. So we'll have x to the power of 5 on 2 all over 5 on 2 plus c, must have the plus c. And again, like we did here, if you have the numerator divided by a fraction, ultimately it looks a little bit neater. If we have 2x to the power of 5 on 2 all over 5 plus c. Alright, so that's a review of the exercise 3.4 and the techniques that we use for doing integration. In this case, indefinite integrals, but all these techniques that we've used here, we're going to need again as we go into exercise 3.5. If you need any refreshers, then get back into that and learn how to do all these things. Get these basic techniques set right so that the following exercises will come more fluently for you.